Now we are going to see how to set up the raster data processing pipeline. So we have two raster data set, the DEM and the LULC map. And just to remember, the LULC is from the National Land Cover data set, and this is what we are using for projections. So to standardize it, all our Albers equal area conic. First, I'm going to change the parameter name so that it's nice and user friendly on the way it shows up on the pop-up window. And once that is done, we are going to do something called the logical coordinate system check. Now the logical check is a ModelBuilder specific pipeline, and in this case what we are doing is that we are trying to check whether the, let's say, the DEM matches the assigned coordinate system or not. It's a Boolean match. If it does, that means if the answer is true, then we copy the raster. If the answer is false, then we reproject it. Now we do have to assign the coordinate system here as a parameter, just because there is no other way to insert the pre-assigned output coordinate system which we have established beforehand to add it here. That's kind of their technical, I would say, weakness, that we have to do it twice. Definitely something that can be improved. So this coordinate system check for the DEM is done because for this study, we know that we did not use DEM's coordinate system, but other case studies may use it. So we do not want to assume that somebody is always going to use the LULC coordinate system. I'm just renaming the frames here so that when the model becomes bigger and there are so many frames, I can still identify them, because otherwise these default names of true false sometimes gets really hard to track back which frame does it relate to or what data it's working with. So I'm going to do the same task for the LULC as well. In this case, I do know that it's the same coordinate system, but irrespective of that, I'm going to set up the same processing where if it's true, I copy the raster as is. If it's false, then I reproject the raster. Now to set up the projection, we need the projection information and we need the cell size, because let's say we have the right projection, but what if the cell size is not right? So we need the user to also insert that cell information. So I will add an empty variable here called cell size, and then I'm going to add that as a parameter and insert that as one of the parameter during project raster. So let's add that to project raster here. We will add it from the false condition. That means if it's not the assigned coordinate system, that's when we are going to do that. So that's going to be set as a precondition, and then the feature, the raster layer should be directly added as an input project raster, and the assigned output coordinate system that we did during the vector analysis will be our output coordinate system. And then we are also assigning the cell size as a parameter, and that we are going to use again the LULC layer as our standard cell size. So we are going to add that as a output cell size. So this is for the DEM in case the projection does not match. We are going to make sure that the DEM also has a snap raster, and in that case we are going to use the LULC as a snap raster. The next one is, what if the projection does match? What do we do? Well, then we just copy the input raster. So we just use the copy raster tool. and we just make sure the cell size is set as a precondition, so that in case the coordinate system is right but the cell size is different, it still kind of resamples the layer to the right cell size. And also it's a good idea to use the snap raster to the LULC, because as soon as there's some sort of geoprocessing going on, there's always a chance to have a little bit of shift. Just to avoid that, snap raster is a good idea. Repeat the same for the LULC layer as well. And so copy raster, project raster. Again, it's a good idea to label those frames so that we are not confused which copy raster is for which layer, because the number of frames are growing, as you can see. And once this is done, you can see that I clicked on to that auto layout to organize the frames nicely, but it kind of did a weird thing that it split up that coordinate system check of 2 rasters into 3 and 1. I don't know why, so sometimes I try to avoid the auto layout, and earlier there used to be different options. For 3.6 it's just one auto layout. But anyway, the next step to this is that once it is projected or not projected, copied, we need to merge those branches, like true and false Boolean branches. Why? Because again, we don't know what our users is going to have, right? So somebody may have DEM as the raster that use as their standard coordinate system. So in that case, irrespective of what is true, what is false, we are going to merge those branches and take whichever layer exists in each of the branches and move forward to the next step, which is the extract by mask step, because that's where we want to clip the raster layers based on the boundary. So first of all, we merge that both the branches of true and false as in values, you can see. And again, it's nice to just rename those branches so that we know which one is LULC and which one is DEM. And I'm clicking on the validate to make sure everything is well linked up, and you can see all the parameters lined up there.